Hello and welcome to today's lesson, where we are in the second of 5 parts of a unit on moving functions around, function shifting. Part 1, we dealt with horizontal shifts, where you could make new functions from old functions by adding or subtracting a number. So you would have g of x equals f of x plus 10, for instance, or minus 10. That moved the function up and down. Today, we're going to talk about moving the function left and right, and what do you have to do to a function to have that happen. So we're going to start with the same basic function we've had, f of x equals x minus 1 squared times x plus 3. That's the equation. Now if I were to ask you to find, say, f of 2x, you would replace all the x's with 2x, or in this case what we're going to really look at today is, what if I were to say find f of x plus 2? Well, you would have to take each of these x's and replace them with an x plus 2. So you'd end up with x plus 2 minus 1 squared, where the x there got replaced with x plus 2 times x plus 2 plus 3. And you would have a new function. Your new function would actually be equivalent to x plus 1 squared times x plus 5. But what if you just were interested in how the graph moved without having to redo all the algebra? If you know something about the zeros of functions, you would know that you now have a 0 at -1 and -5, whereas before you had one at +1 and -3. So you can see you've moved some things around. Well, how does this in general? How does replacing the argument of x with an x plus or minus a number move the graph of a function? So this is the same function we've been starting with, and here are the basic points of our basic function f of x. We're interested in how these points move. So let's take a look at an example. What if I define a new function as g of x is f of x minus 10? So every x in my original function got replaced with x minus 10. Now my original function is here, the blue dots. That's the original function. This solid black curve is g of x. And boy, they look like the same thing, only one is like a copy of the other. And if you look at the points that are of interest, typically the intercepts and the maxes and mins, we can just look at those for now. They have all moved over 10 units. So, but they've moved 10 units to the right. This was f of x minus 10, but what this has done is moved it 10 units, moved the graph 10 units to the right. We would have thought it would have moved to the left. There's going to be a general rule of thumb when you change something inside the parentheses where what we call the argument of the function goes. You change it from an f of x to f of something else. The change, the effect of the change you make with the numbers has kind of the opposite effect as you would expect. You would have thought this would have moved the graph. So you're working with the x, so it's no surprise that you affect the horizontal position. But you might have thought it should move 10 to the left. It doesn't. The graph moves 10 to the right. Because for g of, let's take g of 10. G of 10 is now f, the same y, the y coordinate at x is 10 for function g is f of 10 minus 10, because x is 10, x is 10. So g of 10, what I graph at x is 10 for function g, is the same y value I graphed for function f at x when x was 0 there. So f of 0 is right here, it's 3. So g of 10 becomes 3. We have just picked this up and moved it to the right. Or, since the black function is g of x, if we start here and say, gee, how high does my point need to be at 10? Since it's related to the blue function by this x minus 10, I say, oh, I look at whatever the y was, 10 less than where I am, and that's what I use for y. Same thing here. If I want to know what y value do I use at this point here, I look back 10 units, and I say, oh, There's the y value, but it gets graphed here for function g. So when you have something subtracted in the function argument, you're subtracting from the x, this is different than what we looked at in the last video. This is not within the function argument. This is outside of those parentheses. This does a vertical shift, and it does indeed move down, as you would expect. But this, when you subtract inside the parentheses, is a horizontal shift, and it goes 10 to the right, not to the left. It does the opposite direction that you would expect. Okay, let's go on to another example. Now, what if my function h of x was some f of x plus 5? By the rules I just told you, h of x will be the same shape as f of x, but it'll be moved 5 to the left. So if you're graphing function h and all you have is this blue dotted graph of function f, you could say, all right, I'm at -9. How high does my function have to be? I'm sorry, is that -9? That's -8. I would move at x is -8. Where do I want to put my y value for my new function? Well, I go 5 to the right. So I look at, for x is -8 on g, I look at x equals -8 plus 5, because g of x is f of x plus 5, to find the y value. And I look at that on f. So function f, I'm looking at f of 3. This number would come out to 3. Sorry, -3. F of -3 would be, it would be at 0. So g of -8 is at 0. So each of these points gets moved 5 to the left. You're keeping the same y coordinates, you're just putting them in a different x position. So the x's of g of x are all really 5 less than the x's of f of x. This way, if you look at it from that perspective, x is 5 less than x plus 5. So because I'm making a change and it's grouped within the argument of the function, and it's grouped with the independent variable, with the x, the change affects the horizontal position because x is the horizontal variable, but it affects it in the opposite way I might initially think. I might initially think, I've added 5 to x here, so I'm moving everything 5 to the right. You're not. What you're saying is whatever you graphed for f of x, you're actually going to graph it 5 earlier, which will move it to the left. Let's take a look at another example. What if we have this picture that we've been seeing for f of x? How do we move that around based upon information we're given? So the question here is we want to graph f of x plus 1. And notice this is inside the parentheses. So that means it is a horizontal change, not a vertical change. If it's inside the parentheses, we're not affecting the y. F of x would have been the y. Now you're saying, well, your y for this function is the same as the y at a different value of x for your old function. So it's a horizontal shift and it moves 1 to the left. X plus 1, our gut says it should go to the right, but you do the opposite of what you would think. If you're adding 1, you're moving 1 to the left for a horizontal shift. So to move every point here 1 to the left, you could do it point by point. You could say, okay, this point was -8, 3, and you got to be careful here because these grids are worth 2 each. So I am only changing the left, the x is moving to the left, so now that'll be 1 less for the x, -9, 3. Or you could just move each point 1. Now to move 1 here, I go a half a grid over because these grid lines are worth 2. I'm sorry, these grid lines are not worth 2 each. These grid lines are worth 1 each. Forget what I said about that. So here I'm at -9, 3. And that moves to -10, 3. Here I'm at -8, 3. It moves to -9, 3. You can just see each point moves over 1. And I really only need to do this point and draw a line between them, but it's easier for me to draw that line if well, it's sort of a line. You can see let's Let's see, I do that better. Well, all right. That's sort of the line. And then this point would move again 1 to the left. Each point moves 1 to the left. 1 to the left. This will move 1 to the left and be an open circle. This one up here will be a closed circle. And if I move 1 to the left there, there we go. This green is my new function. This is g of x, and it's equal to f of x plus 1. So if I had instead had f of x plus 1 like that, now I have the plus 1 is in the parentheses, this would have moved it up 1. This moves the function left 1. That's what we just did. So let's take a look at another one. Again, we'll use this same piecewise function. Now I want to graph a function called h of x, and it's going to be the same as if I graphed f of x minus 3. This is going to move the graph 3 to the right. It moves it horizontally because the change is grouped with the x. And when we move it horizontally, minus 3 makes you think 3 to the left, but it does the opposite of what you think. It's 3 to the right. What we're going to do is, for every x in h, we're going to look at what the function value was at 3 less than that x and move it over and plot it at the new x. So I'm moving 3 to the right here, so 1, 2, 3. And that will be a closed circle. That will be the end of my graph. I'm just going to go to this one here. 1, 2, 3. And this point here would be important to plot. 1, 2, 3. When you have a function like this that's got different parts to it, every time the shape of a part changes, that would be a point you would want to place on your graph. 1, 2, 3 for that one, and this one 1, 2, 3, and this is going to be my open circle end. So I go like that, and I'm going to go there, and I'm just going to connect all these points I moved. And you notice the pieces that were lines are still lines, just everything's picked up and moved 3 to the right. And that's because we did x minus 3 in parentheses as my function argument. So here's the summary. If your new function is f of x minus some number, you move that number to the right. If it's x plus that number, you move that many units to the left. When you group your change with the horizontal variable x, you move the function horizontally. There's 2 problems to try. So I'd like you to pause the video and try to graph this one. G of x is f of x minus 4. And then when you're done with that, you can either stop and watch the solution, or you can go on to the next one and then come back and watch both solutions. I'll make a pause between them so you can do them one at a time. So we're going to graph 2 new functions based upon this graph being our original function. Stop the video, try them, and come back. Okay, you're back, so I assume you've tried them. F of x minus 4, this is going to move 4 to the left. It moves it horizontally, side to side. The shape is going to be the same, but I'm going to move this graph 4, I'm sorry, I did that wrong. 4 to the right. See, I made a mistake. It does the opposite. Just the fact that I was in my head saying I'm going to do the opposite of what I think made me catch my mistake. X minus 4 seems like it should be less, but it's actually going to be more. So 4 to the right for this blue circle here is 1, 2, 3, 4. Each grid line is worth 1. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. And 1, 2, 3, 4. Now I could have had a list of points and just changed all the x coordinates by adding 4 to them. So when you move to the right, you do add 4 to each x coordinate. But it looks like you're supposed to be subtracting 4. But if you think of this as x is 4 more than x minus 4, you want to graph this x, so you want to add 4 to each x coordinate, which moves it to the right. 1, 2, 3, 4. So the graph is moved to the right. This will be a closed circle. It's the end of my domain. I draw my lines. I could draw them better on paper or with a ruler, I'm sure. and there is your graph of g of x. Okay, now we're going to take a look at the next one. If you haven't done it yet, stop the video and then come back. The second problem for you to try was with x plus 2 in parentheses. So again, this moves horizontally, and this graph is going to move 2 to the left because this x is 2 less than this 2, so my new x's will be 2 less than my old x's. So the point at x is -8 moves to -10. I can just keep moving these by moving over 2. And I go 1, 2. And up here, 1, 2. I don't have to do all these points, but it's a little easier for me to draw the lines when I draw a few more points. That one goes there. So that goes there. And that line goes there. I'm getting better at that. And then that line goes there. So this is, the green is my graph of h of x. And what you can see is that at x is -10, which is over here, 5, 6, 7, 8, 9, 10, yes. When x is -10, x plus 2 would be -10 plus 2 would be -8. What I've done is, at x is -10, I look at my original function, and I have to look at x is -8 to figure out what the y value should be at this function at -10. That's why it moves it to the left. All right, that's it for today's lesson. Take a look at parts 3, 4, and 5, or review part 1 if you need to, and I will see you next time.